this video, we're going to continue section 10.2, and now we're going to be looking at tessellations with polygons. Um, so a tessellation is basically a geometric pattern with polygons that completely covers a region, okay? Think those bathroom floors that people are always doing with all the little hexagon shapes or something like that, right? Okay, those are tessellations. So let me go ahead and actually define it using mathematical terms. Tessellation is any arrangement in which non-overlapping figures are placed together to cover an entire region. So the idea is they fit together perfectly. Okay, that's what a tessellation is. So an example in nature is a beehive. And anybody who's maybe worked with bees or has seen a beehive, the pattern of a beehive is the hexagon that I mentioned that we see on bathroom floors like crazy. Now, this is supposed to be a regular hexagon, okay? Meaning all the sides are supposed to be equal and they're all touching, but of course, I'm not perfect. Oops. And I don't do a perfect job. That's all right. You get the idea. They repeat over and over and over again, and they fit together perfectly, and we can stack them, and they make all these lovely little shapes and so forth and so on. All right, lovely. Now, where these hexagons meet, these like corners where they meet, wow, mess that up a little bit, Allison. There we go. These corners where they meet, trying to make a big giant spot there. Okay. Allow us to kind of see that they're meeting in a perfect 360 degrees. Okay. They have a name. Oh, a vertex point, where all the vertex angles come together. Vertex point. And we'll talk more about that in a little bit too when we see some other types of tessellations. What's kind of cool, though, is that it has to add up to 360 degrees. It has to. Okay. And I could figure out then from this, I can find the vertex angle for a hexagon or a regular hexagon by taking 360 degrees, dividing it by 3, and that gives me 120 degrees. So that's kind of cool. All right, so we can use tessellations to create some lovely little patterns. But first, we kind of want to figure out what shapes we can use in tessellations because not all the shapes work together nicely. Okay, so we see that a hexagon works. What about an octagon? Can we tessellate? That's supposed to be an A, sorry. It's kind of a weird looking A. Tessellate a regular octagon. I don't know what the hell I was smelling there. Octagon. I can do this. Wow. Oh, maybe I've had a stroke. Okay. So what we have to do is figure out then if we can create that vertex angle, right? If we fit octagons together, do they fit into that 360-degree pattern? So let me go ahead and draw an octagon here. I'm not going to actually attempt to draw this. That's annoying, especially because I'm freehanding this, right? Okay. I hope you remember earlier in the last video, we had actually figured out the sum of the angles of an octagon by doing 3 quadrilaterals. Here's how I did it. And 3 times 360 was 1,080. If you remember that, great. You don't have to show the picture. Okay. But if you don't remember that, we need that 1,080. And that would mean then that the vertex angle for an octagon is 1,080 divided by 8, which comes out to 135. Okay. So if I take 135 and I subtract that from 360, basically I'm going to see if I can just keep subtracting until I get to 0. Okay. So let's see. Actually, you know what? Easier way. Take 360. I don't know why I didn't think of this. And divide it by 135. And we could see if it goes in evenly. So grab your calculator and plug that in. All right, I get 2.67, well, 2.6 repeating. So 2.67, and therefore, no, you can't tessellate it. So no is the final answer, because it doesn't go in evenly. If it went in evenly, yes, we could tessellate the octagon. That doesn't mean we can't tessellate with an octagon and another shape. In that case, we call that a semi-regular tessellation. So a tessellation of 2 or more non-congruent figures is called a semi-regular. Oh, actually here, they don't just do figures. Non-congruent regular polygons. Regular polygons. So we are using right now polygons that are regular. It doesn't have to be, but we're making our life a little bit easier that way. Okay. Tessellation of 2 or more non-congruent regular polygons is called a semi-regular tessellation. Okay. So I mentioned octagon can work. We just need to pair it with the right other polygon. Okay. And I'll go ahead and give it to you. Octagon and a square actually work out really well. Okay. Here's how I know that. This is the one where I wanted to subtract from 360. Okay, so I'll take the 135 away from 360, okay, and 90 degrees, because that's a square. And let's see what I'm left with. So if I take 135 minus 90 from the 360, I get 135. Okay, so here, that implies that if I have 2 octagons and 1 square, that will make the right 360 degree vertex point. Okay, so I'm gonna attempt to draw this, and I'm not gonna go very far with this. Okay, maybe just a couple octagons. I'm gonna do my best to make them as equally sided as I can. Yeah, that wasn't at all. All right, and then here we'll draw another one over here. 2 octagons. And then this, if I had drawn it well, would have been a square. And this down here is another square. Oops, let's not make it look weird and wonky. There we go. Okay, so this is supposed to be 1 octagon, 1 octagon, 1 square. And those form the 360 degrees. So the vertex point, we can actually do a really cool thing where we create a code for the vertex point and indicate the shape of the polygons, the how many sides they have that make a good vertex point. Okay, so the code would be 8, 8, 4. So 2 octagons and a square. All right, moving right along with tessellations. Now here's where I actually had to practice. before I'm doing this. And who knows, I might mess it up pretty bad. Let's tessellate a letter. Tessellate. Wow. Tessellate the letter A. Okay. I tried not to pick one that you'll be tessellating. All right. And these are a lot more challenging than they seem. Okay, so here's how I'm going to do this. In order to do this properly, I need a grid. So here, I'm going to actually change the background so that I have squares. Okay. And I'm going to probably have to zoom in here to make this work. All right. Okay, I'm going to tessellate the letter A. So here's what I'm going to do. I'm basically going to follow the slope pattern. 2, 3, sorry, 1, 2, 3, 4, 5, 6 of going a slope of 2. Okay, this is like a slope of 2 because I wanted to draw it really well for you. All right, and then I'm going to repeat that on the other side. I'm going to try to 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So draw it on the other side. Got the dots. All right, there we go. Okay, so then I'm going to go ahead and draw, oops, the bottom. It's being fussy, sorry, because I'm trying to draw it a little too zoomed out. There we go. That might help a bit. Okay, or it just happens to be that my pen is not completely. All right, so it was this part over here that does not want to line up nicely. There we go. Okay, and then I'm going to follow the slope pattern. Up. Inward. All right, and then I believe I make a little triangle like this. Oops. Sorry. Okay, there's my first A. And now what's kind of cool is I can tessellate with another A going upside down. So there's the leg. And I'm going to continue that pattern. Or, oops, sorry, I did that too sharp. Should be out over here. And then 1, 2, 3, 4. Okay. There's the top part. And then I'm going to go out this way. You, of course, do not have to be this precise. I'm just trying to show you how precise we can get. And here's my little triangle, and there we go. And we could fit them together perfectly. I can draw another A going this direction down here. And oops. And then draw the flat piece here. And there's going to be the triangle. You kind of get the idea. I can keep drawing these tessellating A's. Two upside down and then, oops, two upside down and then two right side up. And I can just keep doing this pattern and tessellate them over and over and over again. Oops. And so forth. You get the idea. I can keep building these figures with the A's over and over again and making these capital letters. Okay, so you'll get the opportunity to do some tessellating in the homework, and you do not have to be this precise. But if you're slightly anal retentive like me, you may want to get some graph paper and try your best to figure out which shapes basically you can kind of repeat over and over again. Don't be afraid to look at the back of the book to do these, okay, to actually make the shape work. But let me go ahead and zoom out and we can see it. There's my tessellated letter A. Hey, I don't know. It's not too terrible. You can see the letters rotated and repeating. And there is tessellations.